Hello, welcome to the NCS4 Research Seminar Series. We're happy that you could join us today. This is an opportunity where we can share relevant research output with the industry at large. So today we're going to be covering some information on railing height. So going off the rails, and this will be presented by Dr. Kocak, Dr. Grant, and Dr. Freed. So before we get into content, really just wanted to give a moment for each one of them to introduce themselves. If you could, Dr. Kocak.
Hello, this is Dr. Kocak. I'm an assistant professor in construction management program at University of West Florida. My research area is mainly related to the materials, construction materials, and both in earth and the Martian and the lunar surface. So this project is one of those material related projects. I'll be presenting the design and some material aspects of the guardrails. Thank you.
My name is Aneurin Grant. I'm an associate professor in the construction management program at the University of West Florida. And my contribution to this webinar is primarily based on the building codes, the standards, and also I teach construction safety here at the University of West Florida. So there's also some relevant information there.
And hi, everyone. My name is Gil Freed. Some of you might know me from my work in the venue management space. I am a professor at the University of West Florida. I'm the department chair of the administration and law department, of which both sport management and construction management are two of the programs I have the pleasure of working with. And the purpose of this presentation is a couple-fold. One, to highlight the issue of fan injuries and death associated with falling over railing or maybe falling down if a railing in fact collapses, which sometimes does occur. The second part is to examine whether the line of sight exemption at 26 inches is in fact safe. Third is to analyze the load of force concern associated with fans leaning against railing and whether or not that is something that causes railings to possibly collapse. And the last one is to offer some solutions. And so that's how we'd like to portray this presentation, is we're going to be discussing what the issue is, discussing some of the elements associated with it, such as what is appropriate railing height, why do they decide on certain railing heights, and what are some of the standards. And then we go into some of the safety issues associated with these various standards and whether or not they're appropriate and accurate based upon what actually goes on a day-to-day basis. And then most importantly, we're giving you some solutions. And that's, I think, the thing that everyone is looking for. So let's go to the next slide, please. This has been in the news. And I think we've been seeing it for a number of years that people have been injuring themselves in a wide variety of ways. And I understand with the folks that are members of NCS4 and those that might be listening to this webinar, that you probably have seen stories over the years on a wide variety of different issues. Some of them are pretty well-known cases. Some of them are not as well-known cases. Some of them have led to litigation. And as someone who's been an expert witness in several of these cases involving people that have fallen to either their death or catastrophic injuries, I can give that perspective as well to highlight that, you know what, if we can avoid this, it's great, not just for the safety reason of making sure people are safe, but also for the fact that the litigation and the settlements or the jury verdicts could be significant. And that's what we're trying to do, is minimize those impacts. So let's just start off with some initial research that was done by Weeks and Gorman. They put out a book called Death at the Ballpark. And if you have not seen this book, I recommend you read it. It's not something that will help you go to sleep at night. It will basically scare the living bejeebers out of a lot of you, because people die the weirdest ways possible. Like someone peeling back, I think in the 1920s or 30s, an apple with a pocket knife, and they got hit with a foul ball, and then the pocket knife got jabbed into their heart. Weird things, but they went through newspaper articles for years and years, and they highlighted a lot of different things. And as an example, from 1969 to 2011, and the book came out initially in 2012, there had been 22 fall-related fatalities at major league ballparks. We're not talking about minor league. These are just at the major league level. So as someone who teaches sport law, the first thing I think about when I'm seeing these kind of numbers, is it foreseeable? And that's the thing that we're trying to take a look at, is that the numbers give us some kind of warning, and we have to take steps when we are warned to make sure we make the venue as safe as possible. There also was an article put out in Athletic Business magazine by Steinbach in 2009, and he highlighted a 9-year period from 2000 to 2009 where there were 3 deaths and 8 serious injuries associated with railing-related incidents. And normally this is going to be someone falling over the railing or railing collapse. So that's why we are taking a look at this specific area, because there are injuries, there are deaths, and we have to make sure we provide the safest environment possible. Next slide, please. So there was a study that was done by ESPN, and they highlighted 1 death at Coors Field in Denver in 2011, 1 at Turner Field in Atlanta in May 2008, and 1 at Shea Stadium in New York in 2008 as well. And those were all highlighted as examples of deaths from people falling over railing. So it's not just this is obscure news somewhere. ESPN was highlighting and showing how relevant and critical this is as a safety issue. One of the cases that they highlighted involved an unfortunate incident in 2009 at a St. Louis Cardinals game, where a fan fell over a 30-inch rail on the front porch row of what was called the Casino Queen Party Porch section at Busch Stadium. Shortly thereafter, a 34-year-old by the name of Chris Hoffman passed out from dehydration and fell over on the 4th deck as well. So these are examples that are very scary, not just for the people that are falling, but for the people that are managing the venues and the crowd managers and things like that. On April 25th, 2010, there's an example of Stuart Springs Tube. I hope I'm not butchering his name, but he suffered a fatal injury after he fell 15 feet over a railing while trying to catch a ball. So this happened during batting practice. So it's not just during the game itself. It could be before the game, or I've had an incident where a railing collapsed at the end of a game during a celebration. And the Springs Tube case, that happened at Miller Park during a Milwaukee Brewers game. The same season, Tyler Morris, another fan, fell over a 30-inch rail at a Texas Ranger baseball game, and that was in 2010. And so if we're starting to take a look at this, you might start seeing some trends. We're looking at heights of railing that are close to 30 inches. And so if a number of people are falling over 30 inches, is that a relevant height? And then what does that mean when you have the International Building Code that gives an exemption that you can have it even lower than that at 26 inches? And a lot of venues utilize 26 inches as the amount of their barrier because it's the line of sight exemption. We're going to be covering that later on, but this goes to put us on notice and warn us that 30 inches probably is not enough when people are falling over it. Next slide, please. Yet there are more incidences, and some of them are getting to be quicker. Unfortunately, the picture got moved on the slide there, and I don't know if we can correct that, but I'll just start going through some of these. 39-year-old Shannon Stone fell to his death over a 33-inch railing. That is going to be looked at a different slide. That happened in Texas. He was leaning over to get a ball that was going to be tossed up to him by one of the players. And he was just leaning over, and he fell all the way over and unfortunately died right in front of his son. So that was a major one. And the Texas Rangers, as a result of that, increased the height of railing around their ballpark thereafter. In 2014, let's go back. Thank you. In 2014, a toddler was hospitalized after tumbling down a railing at the American Airlines Center in Dallas. And that was during one of the circus event shows that was going on. Sometimes the railing-related incidents that we see are actually associated with not falling over a front row guardrail, but maybe trying to ride an escalator or a guardrail on stairs. And then someone might be intoxicated, and we're going to be going over that in a little bit about how we get people in a wide variety of different states. And we have to expect that, as I like to tell my students, expect the unexpected. And people have a constitutional right to be an idiot. And so you might have a situation where you're going to have people doing stupid things like being 4 stories, 5 stories up high and trying to ride it a railing down and losing their balance and falling, unfortunately, to their death. So that has occurred as well. In 2016, a man was injured after falling over a railing at Oracle Arena following an NBA Finals game. And this isn't just stuff that was years ago. This past season, baseball season, so the 2021 baseball season, a mother and toddler died. They were dancing on top of the picnic table in this photo, and they fell over the railing, unfortunately, to their death. A couple days later, if I'm not mistaken, another person fell over the railings at a concert in San Francisco. In that case, it was, at least the initial opinion is that it was suicide because he intentionally tried to jump. Who knows if he was on drugs or intoxicated? We don't know all the facts, at least at the present time. I don't know all the facts. But at the same concert, somebody else got bumped and fell over and got seriously injured as well. And that person was not in the front row. They were actually up, maybe the second or third row. I don't know exactly which one, but it wasn't in the front row. They just lost their balance at a certain point because of whatever reason, and then they fell over. So these are incidences that are impacting us. Next slide. So here's an example of what's going on. You can see the railing in front of Mr. Stone. Mr. Stone is wearing the khaki shorts, the white shirt, and the blue cap, and it looks like he is trying to lean over. You could see the railing is below his waist level if you were to stand up straight. And then if we look at the next slide, he fell over right in front of his son. That's what you see there. And as it, unfortunately, he passed away, and that's a picture of him. In fact, the Texas Rangers built a memorial for him, and there is a statue of him and his son outside the ballpark. But it's just a really tragic event and really shook up a lot of people. Next. So this is not just the only type of injury that we're going to be seeing when we look at whether it's seating area, grandstand, portable bleachers, you name it. This has been something that's been on the radar for a number of years. In fact, in the year 2000, the Consumer Product Safety Commission came out with a report. It was a guideline for retrofitting bleachers. And the reason why they put it out is that they had so many complaints that they had received from people being injured on bleachers, in stadiums, in arenas, portable bleachers, telescoping bleachers, you name it. And part of that was that there was, on average, about 19,000 bleacher-associated injuries treated in ERs every year. That's 19,000, and that's just a huge number. Of that, about 6,100 of those injuries were the result of falls. And that could be falling off the back of bleachers, falling off the sides, or falling from the front, or falling in between. I remember as a youngster running stadium steps at Stanford University, and it was old rickety wood bleachers there, probably built in the 20s or 30s. And when you look down, you could look down 50, 60 feet. And, it got me petrified of heights, actually, from having to run that as an athlete. And some of the conclusions by the Consumer Product Safety Commission is that the top surface of a bleacher's guardrail should be at least 42 inches above the leading edge. And so they're allocating 42-inch height railing. The recommendation was endorsed by the National Fire Protection Association with their Life Safety Code, the International Building Code, the International Code Council, National Building Code, BOCA, which is the Building Officials and Code Administrator, the 1997 Uniform Building Code, and the 1997 Standard Building Code. These are all advocating saying, yeah, you should have 42 inches. And that is what the code requires, and we're going to be covering that in a little bit. But there is an exception, and we're going to be discussing that exception as we move forward. Next slide, please. Other concerns. This is probably the most relevant one on a day-to-day basis is litigation. We're going to have people that are going to get injured in the stands all the time, no matter what. It could be a slip and fall, trip and fall. It could be a bee sting. It could be a heart attack. It could be a heat stroke. You name it. We get to face it on a regular basis, and that's why we have medical staff available. That's why we train people as in first aid and things like that. But we're also seeing cases. One of them is Greg Ace Murray, who died at Atlanta Braves game. He was actually on the second row. He wasn't at the first row. He was on the second row and had possibly a medical incident. I don't remember the exact cause of it, but he ended up falling over and he died. And this led to litigation. This is only one example of litigation. And as part of that litigation, Rankin wrote an article about this in 2019. Major League Baseball had received a warning from their risk management professionals. It was an outside insurance adjuster who said after the Stone incident, you know what, this could happen and we got to be careful of it, that it's likely going to happen. And his suggestion, this outside insurance consultant, was maybe you should put netting in place as a way to try to protect people, that if they do fall, the netting might in fact catch them. And there are venues in, I think it's Seattle and Chicago, where they have Major League Baseball stadiums where they do have it, the netting. And so it is an option. We're going to be covering that later on. But I don't want us just to focus on people that might have fallen over railings. There's a whole lot of other issues as well. And some of it could be railing collapses. I've handled the case before involving an MLS championship game at the good old RFK Stadium, which, if I'm not mistaken, it probably, if it hasn't been condemned and torn down, it's in that process of being torn down. And I remember when chunks of cement were falling from up above, and they had to put things to protect fans from chunks of cement falling on them. And so what happened was, at the end of an MLS game, the players went to one location. All these fans went over there because they wanted to reach out to them, to touch them, to grab them, and to connect with the players. And while they were doing it, the railing came up and they all fell down. Luckily, it wasn't a significant fall. Similarly, there was a significant railing collapse at the Michigan-Wisconsin football game at Camp Randall Stadium in 1991, if I'm not mistaken, or 92. I forget exactly the year of the incident. But 77 lifeless non-breathers had to be resuscitated and taken to hospitals and things like that for a wide variety of different issues, a lot of them being asphyxiation. But some of it also was personal injury from people being pushed against railings. And the people had so much power behind them that it was able to twist the railing like it was a piece of string. And Dr. Kocak is going to be taking a look at that and the load and how much pressure is. But this is not something that just happened years ago. This past football season, there was an example of Jalen Hurt in Philadelphia, from Philadelphia. He was going out of an exit tunnel to exit the field, and some fans wanted to get close to him. And it was in ADA specialized seating area. All the fans leaning over, it collapsed and they all fell. Luckily, none of them were seriously injured and no players were injured. But it just goes to show this is something that is critical for us in terms of understanding the height, understanding the dynamics of how people fall, and understanding the construction issues that might be associated with it. And I don't want to just end it with construction. It's also renovation and constant maintenance and repair to make sure something is in the best shape possible. With that, I'm concluding my remarks, and then I think we're going to Dr. Grant for a little bit. So next slide.
Yeah, I think we're going to me for a little bit. This slide, I wanted to include this as part of the history of a fall, and I teach this slide as part of a construction safety class. Construction is so especially dangerous that we are lucky enough to have our own standard for safety. Mining would be the other one, maritime, in addition to general industry. But the cases and the incidents are so high in construction that we have our own standard. I teach this graphic when I'm teaching subpart M, which is on fall protection. You'll notice over on the far right column, it'll talk about fall arrest systems. So this table is in fact more closely related to personal fall arrest systems than it is to guardrails. However, that's not the most fascinating part of this table, if you ask me. The most fascinating part is the far left column, or red ladder, if you will. It's an elapsed time in seconds of how long it takes to fall a particular height. And then the other thing that I think is particularly interesting about this table is the speed you would attain in miles per hour during that short period of time. The one that we focus on in my class is 6 feet, which will be the 72-inch elevation. 6 feet happens to be the maximum free fall distance if you're wearing a personal fall arrest system. But if you think about that, I can fall 6 feet in less than a second. And I don't know, I have some student athletes in my class who think they can test their reflexes, but 0.61 of a second, that really happens before you even know what's going on. You've fallen, and not only have you fallen, but you've dropped a full 6 feet. The other one I think that's relevant here is maybe the 193 inches. That's a little over 16 feet. That takes a full second to get to 16 feet. The other thing that is relevant here is those two, the speed that you would get up to. So to fall 6 feet, you get up to 13 miles an hour. To fall 16 feet, you get all the way up to 22. And that might not be like staggering in terms of a speed, but if you can envision just standing in the middle of a road and getting hit, not by a car, but a concrete wall while you're completely unprepared for it. There's other issues too. If you fall on your back, then you get sort of a whiplash motion in your neck, which can further accelerate the speed of your head to the surface below. So the thing I like to highlight with my students is that it's going to happen before you know it, and it's going to be too late to react. So the other thing I do have some experience with is looking at the OSHA fatality and catastrophic incident database, which is not like the most uplifting reading I've ever done, but I can tell you that reading that database, there are incidents where people fall a matter of 2, 3, 4 feet. 6 feet is pretty regular and actually die. So it doesn't take much of a fall. The only other thing I'd add to this slide is it's not just the person falling, it might be the person that they're falling onto. So that also can, when we teach subpart M here, we teach it with that perspective in mind. It's not just the person falling, but it also could be something like an object or a person that I'm falling onto. So that's really all I wanted to cover on that slide, and we can go to the next one.
In this slide, I'll be talking a lot about the design criteria, and falling over elevated surfaces is one of the most common causes of the serious injuries and the death. They can be prevented by using a proper fall protection system, such as the guardrail system, safety nets, fall arrest systems, and in some cases, even the positioning device systems. Since the fall protection system is a really wide area, our focus mainly is going to be in the guardrail systems in this presentation. And let's start with the design criteria. First of all, there is no single guardrail design that works for all situations. So there are different code requirements which update frequently, and they have to be applied for each specific application. Design criteria for the guardrail systems are set by the governing code for the area in which the systems will be used. So the first one is the local codes. They generally follow the requirements established by the International Building Codes and Occupational Safety and Health Administration, shortly OSHA. And the second one is the IBC itself, the International Building Codes. Section 1013 outlines the general information about the guardrail requirements, and section 1607-8, it is really focuses on the loads of the guards. And the third one is the Occupational Safety and Health Administration one. OSHA fault protection requirements for general industry and as well as the construction are addressed in the Code of Federal Regulations. And of course, the governing codes must also be checked for their specific requirement and the government regulations, such as the Americans with Disabilities Act, ADA. And in the design of the guardrail systems, 3 requirements are essential along with some others. And these are material requirements, loading requirements, and as well as the height requirements. Now let's see these requirements in detail a little bit. Okay, the first design criterion is related to the material requirements, and the railing systems can be fabricated using different materials, and some of them are like the steel, anodized aluminum, cables, wires, glass, concrete, wood, copper, brass, and even composite materials, and even more like the PVCs and a vinyl. While some of the railing materials, such as brass, very popular these days because of its ability to inactivate the bacteria and the viruses for less than an hour, some other materials can really provide a better affordability, visual appeal, and better visibility. Regardless of the type of the material, actually, certain benefits they provide, but the primary goal, primary purpose of all these railings is the safety. And most frequently used guardrail materials in the OSHA and the IBC specifications, along with the NAAM, which I'll explain shortly. This is the carbon steel, and carbon steel can be in the shape of the pipe or a structural tubing. And carbon steel is structural carbon steel really has a high mechanical strength properties, which is really good. And this allows us a wider spans between the support posts of the guardrail systems. And typically they are cost less than the aluminum pipes or tubing, but steel pipes cost less than the aluminum pipes and the tubing, but tubing is costlier than the aluminum alloys, any type of it actually. And this pricing, as you can appreciate, changes depending on the supply and chain issues that we are having even nowadays during the COVID era. So one downside actually of the structural carbon steel is the low corrosion resistance. So they have to be finished either by painting or really hot dip galvanizing, so that it's going to make them less vulnerable for the corrosion. And the second most used guardrail material is the aluminum alloys, and it is in the shape of pipes or the tubes. Aluminums are generally preferred because they are really the lightweight and corrosion resistant, and really they have the good structural properties. But of course, there are 2 main concerns related with the aluminum. And first is the welding. Welding looks good on the aluminum instead of using the mechanical connections such as bolts. And however, welding the aluminum is really reducing the heat, is creating a stress concentrations in the points, and it is reducing the allowable bending stress considerably. That's why it has to be taken into account during the design process. And the second concern is embedding the aluminum post into the reinforced concrete, especially the reinforced structural concrete, in a corrosive environment. So both of these concerns should be addressed during the design process. And the third material that we are really using frequently as a railing material is the stainless steel. And stainless steel can come in the form of stainless steel pipe or stainless steel tubing. This is really the most expensive option as of today compared to the carbon steel and the aluminum, but of course it has the minimal corrosion impact. And of course, these are like the main ones, but the mechanical and physical properties of all these materials can be seen in the National Association of Architectural Metal Manufacturer publications. and they are providing all the information related to any of this stainless steel, carbon steel, and also as well as the aluminum alloys. And in general, there is no really one magic material. I wish it was, but if you look at the OSHA and the IBC loading requirements and the experiences that we learned from the constructions, in general, one of these materials, carbon steel or stainless steel or aluminum tubing and the piping, around 1.5 inch the diameter. So it is really working to carry the load requirements that I am going to be covering shortly. And here, if you would like to really summarize the selection criteria for metal alloys for the guardrail system, the very first one is the strength requirement. That's important. The second one, as you can appreciate, is the corrosion resistance. Third one is going to be the joint connections, welded or non-welded. And of course, the other one going to be the costs. And these are like the four main considerations that we have to take into account during the selection of the guardrail material. And it's worth noting here that these are like really the four main considerations, but again, code requirements, material and labor availability in the specific area, as well as the cost of material and labor, and some other parameters can also impact the material selection criteria, and this has to be kept in mind as well. Okay. Second design criteria that we are going to be seeing is the load requirement. This is the really one of the important topics. So there are different load requirements set by the different coding bodies, while OSHA really specifies the concentrated loads. IBC, the International Building Codes, it takes into account both concentrated load as well as the uniformly distributed loads. And they are using really the American Society of Civil Engineering minimum design load criteria, ASC 7. And here, as you can see from this drawing, the first drawing, the distributed loading is specified by some building codes, and it is really representing the force exerted by like tightly grouped people leaning on or pressing against the railing. So this loading requirement is outlined in the IBC section 1013, guards, and 1607, and loads on handrails and the guards. So this is really telling us that this loading requirement ranges between 20 to 50 pounds per linear foot, applied to the top rail depending on the area of the occupancy load. So in our cases, it is the highest value, as you can see from the right drawing here, which is 50 pounds per foot. So we are really taking into considering the highest value here. And the other one actually here is the second loading case. And this loading case represents the force exerted by a single individual leaning on or over the rail. Or the most important thing actually, that a person or an object impacting upon the rail. So OSHA fall protection requirement for the general industry really addresses on this one in the Code of Federal Regulations. And a number of codes and the governing regulatory agencies require us as structural designers to use 200 pounds of a concentrated load applied in any direction at any point along the top rail, because it is the most critical one for the strength design of the rail systems. It is worth reminding actually here that these are the minimum requirements, both the uniformly distributed load or the concentrated load, and they need to be satisfied, and they are not applied at the same time according to the codes, either or. So sometimes the question is coming, what happens when there's a pile of people against the guardrail while the crowd is cheering? You know, unfortunately, the codes do not address these problems yet. And this is some things in nowadays we are seeing a lot as a problem. So in the upcoming updates, most probably these concerns will be addressed as well. And let's see the other loading requirements related to the guardrail systems. And here, this figure actually demonstrates an example of a standard guardrail. And if we technically describe the guardrail, guardrails are nothing but the barriers having vertical supports spaced at certain distances and horizontal parts named as like the bottom rail or toe board sometimes, and the mid rail. If there's no mid rail, sometimes they have the intermediate rails and the top rails. And the space between these vertical and the horizontal members is filled with various materials. And those materials are called as like the infills or the balusters, you know. And finally, of course, the most important part of the system is the connections. They are, excuse me, they are either embedded, anchored, bolted, welded, and sometimes even if there is a wood structure, they are screwed, depending on the structure they are constructed on. Excuse me. Of course, not only the but all these parts individually should be designed. And in general, the distance between the support posts are like 60 inches. OSHA limits maximum on center opening to 96 inches, which is 8 feet. But in some other codes, allow, if there is no public allowed to enter, and they allow it up to 120 inches span length. As you can imagine, when you use, when we just explained, when we use a different material, carbon steel, you can go wider openings. So this span length changes according to that one. And the other thing is the infills. Infills are really an important part of the guardrail system. And these materials are filling the space between the post and the rails so that it can provide a protection against falling. And although glass and like the clear plastic infills are the ones commonly preferred because of the better vision that they provide, but there are like the tension cables, stainless steel rods, horizontal and vertical pickets, and the laminated glass, etched glass, resin railing panels. These are like some of the infill materials using in the railing systems. And one thing is, independent on the material used, infills must be strong enough to resist a 50 pound per square feet of a load requirement set by the IBC section 16078. And also the codes require for the infills and the blasters that they should not be larger enough to let a 4-inch diameter sphere pass through. This is really set. It's a good requirement that is set to prevent the head of a small child getting stuck between the infills. And here, if there's an impact load coming to the, our infills, this load is going to be distributed to the rails, and through the rails, the load is going to go to the support bars, and the support bars are going to carry this load all the way to the anchor or the embedment to the structure that sits on it. So through the anchoring system, the load is going to the structure itself and disappears over there. So since this is the trace of the load, we have to be really designing every single element here carefully so that none of them are going to be the weakest chain here, so that our structure, the guardrail, is going to do the job. And here the height requirement, it is least but not the least important, last but not least important requirement set by the codes. So the usefulness of the guardrails actually to prevent falling over is directly related to the height of the top rail. And as stated in the codes, the top rail should be a minimum of 42 inches from the walking surface. But here is the question. So which of the one that I'm going to show here the safest according to the 6.5 feet tall population? So here, first of all, I would like to explain something before answering this. The height of the guardrails are determined according to the center of gravity of the human beings. And according to the authorities, the center of the gravity of a body, it's a hypothetical point, but it is like approximately 3 inches above someone's mid height. Okay, so, and when we apply this to the data that we are getting from the National Center for Health Statistics and to the 99th percentile of the population height in the states, we are seeing that 6.5 feet or 6 feet 6 inches or 7 8 inches. So this is like a person with a 7 8 inches tall. He'll have a center of gravity of a body which is 3 inches above the mid height of it. So 7 8, half of it is 39, and 3 inches above it, it is exactly 42 inches. This is equal to the height of the top rail on the guard rails. So this is what the number is coming, honestly. And this implies that actually people shorter than 6.5 feet tall will have a center of gravity of the body below the guardrail and possibly will rotate under the top rail, whereas the people taller than 6.5 feet will rotate over the top rail by falling against rail and probably tumbling. So these issues really should be addressed in any changes, any updates, and 42 inches is really the option right now that we have, plus minus 3, and there's another option like the 30 or the 36 inches top rail, and the third option is line of sight option, and the exception actually, this is like the 26 inches. So these are all available, even more than these ones, but these are all the available heights for the guardrail systems. So which one is the safest for the 6.5 feet tall US population? Of course, it is gonna be the one which is option A. Okay, and I would like to leave this space to Dr. Grant. He will be going to the standards and regulations.
All right, thank you. I think there's some of this is going to be a little bit of repetition, but you will get a specific reference as to where some of these numbers come from. We thought that the OSHA standard was relevant because it has its own subpart for one, but it's also got its own subsection, which is fall protection, and we take falls very seriously. Just as a disclaimer, there are some similarities and parallels between the OSHA standard and the building code, and there are some differences, and I will point those out as we go along. As according to 29 CFR, so that's Code of Federal Regulations 1926, those are specifically the construction standards. Guardrails need to be a minimum of 42 inches high, plus or minus 3. Now, that can be 39 inches, anywhere between 39 and 45 inches. 39 is most probably applicable to what we would use in a wire rope during steel erection. So there's obviously going to be a little bit more deflection in a wire rope than maybe a solid member. The 45, I think we often use scaffolds or the cross braces of scaffolds as the top rail. You have that option in a different subpart of the standard. So we do give a little bit of latitude to that 42 inches, but the 42 is aligns pretty much with what's written in the International Building Code. You'll also recognize probably the 200 pounds down and out. That's in the direction of the observed fall hazard. So if I've got a hole right here, you don't want the guardrail yielding in the direction of the fall. The other thing that is important to talk about in terms of the OSHA standard similarity between that and the building code, and even like just for basic facilities maintenance, there's a couple of things that I really wanted to highlight. One is housekeeping. So throughout the OSHA standard, we have references to housekeeping. Housekeeping in general is a good safety practice. Compliance officers, when they arrive on site, they often say that they can tell the difference between a unsafe job site and a safe job site immediately just by its appearance. So that'll relate to the way that the materials are stored, the sight lines, the way things are organized, if vegetation is overgrown, or if there's just garbage and debris on the ground. So if it's a messy job site, I think they get out their book and get ready to take notes. If it's clean, then that basically gives you an atmosphere of safety. I used to work for a company that used to use a statistic that 40% of construction industries were attributable, at least either directly or indirectly, to poor housekeeping. So we were very big on housekeeping. The other important consideration is that poor housekeeping leads to slips, trips, and falls. I'll tell you why that's relevant to stadiums in a second. The other thing that we see throughout the OHSA standard are references to horseplay. I have a couple of other slides about what horseplay is. I've also seen the word horseplay used specifically in construction contracts as a prohibited behavior. We'll get into exactly what that means. Why is that relevant to stadiums? Because if you think about the way the fans behave, it could be likened to horseplay. Likewise, I don't know if, stepping on somebody's nachos would be a good example of bad housekeeping, but people's legs and arms moving here and there, those present a tripping hazard. So there's things that we tolerate in stadiums that we absolutely would never tolerate on a construction site. May I have the next slide, please?
If I could just interject for a second, would you think that the housekeeping component of OSHA would apply in stadiums and arenas for the people that are working there, such as people that are hawkers, you have security personnel, you have ushers, and things like that? And so it's not just the fan safety. What if you are a concession worker who has their back to the game, and you move back and you tip over? Would that be an OSHA related issue?
I think it's directly related to what we're talking about. So if it's somebody throwing you a box of Cracker Jacks and you have to lean one way or another, or even somebody kind of leaning out and using the passageways to jump up and down, I think the sheer movement of people and it's almost like the encouragement of people to kind of act in that way. It's just inconsistent with what we would allow on a construction site. So we have clear lines of movement if we're being safe. We're certainly not leaning over and grabbing for things. That applies to ladder safety too. So the rule for ladder safety is that you keep your waist within the two runners of the ladder. So there's things in stadiums, behaviors exhibited that are really inconsistent with what you might see as safety regulations in another environment. All right, I think everybody's kind of heard the term horseplay for one time or another. I think my parents used to ask me to stop horsing around. The general definition is that it's sort of vigorous or sort of rough play. It could result in unintentional physical harm. In my teenage years, I probably horsed around a little bit more than I should have, and that could be in relation to, giving somebody a jump scare or throwing an object at somebody in the, think quick. But yeah, horseplay is just essentially that. It's rough play. It's completely not tolerated on construction sites. I would say that there's a little bit more tolerance for that in sporting facilities, almost an encouragement in some ways. May I have the next slide, please? These examples of horseplay are most relevant to construction. So, I mean, we're not going to have an excavator in the stadium splashing water at people, but I think there are a couple examples in here that might play out in construction. So the last bullet point on the left says playfully throwing a work tool at a fellow worker. And yeah, you might think like, don't throw a hammer at me. That's not funny. Maybe it's something a little less solid, but if you're forced to be aware of your surroundings and you're trying to be safety conscious and somebody is giving you something out of the blue that you're forced to react to in a way that can be really dangerous in certain construction operations. The other example I can think of is, if my kids, when they were younger, they would go to a swimming pool and it would be like, who can push dad in the quickest, or who can who can push each other in the quickest. And if you think about that, lifeguards probably frown on it too, for the exact same reason that we're talking about horseplay right now, is that if, in going to push somebody off the edge, they lose their balance and they hit their head on the side of the pool deck, that doesn't feel really good either. So it's not tolerated in swimming pools. It's not tolerated in construction sites, but sometimes I think we give a little bit of latitude to horseplay in stadiums. May I have the next slide, please? So the example, I think Dr. Freed had given some examples about people taking selfies and being preoccupied with that type of situation. The other one I think we talked about was t-shirt cannons. And as soon as I see a t-shirt cannon, I think, oh, cool. Like, it shoots stuff out of things and there's an explosion and look how far it flies. But if you think about what you're encouraging with a t-shirt cannon, you're basically, I've seen fans compete for fly balls. I've seen them compete for t-shirts, sometimes pretty aggressively. I don't know of any documented case where somebody's fallen over a guardrail for diving for a t-shirt. But at the same time, you just have to think of the spirit of behavior. Yeah, you want people to have fun at the ballpark, but at what cost? May I have the next slide, please?
So, Nye, just to add to that, there have been, not about falls, but have been lawsuits with people hit in the eye by t-shirts, and they have sued from t-shirt cannon. And there also was a famous case in Kansas City where someone was hit by a hot dog thrown by a hot dog vendor.
Oh, God.
And got injured and sued.
I don't want to be hit in the head by a hot dog. It's not the way I want to get injured. But no, I think you raise a good point. It's not just when you talk about falls, sometimes, at least when we talk about it in construction safety, we're not just talking about the person falling. Sometimes we're talking about the object flying or whatever may be the case. I think there's probably a difference between a hot dog and a t-shirt and a hammer, or a bucket of nails or a bucket of bolts. I'd rather get hit by the hot dog personally, but I think there are some instances here where we got to realize that it's not just the person, but there's also objects flying through the air. This is a foreign example, so I don't mean to pick on Argentina, but these are Boca Juniors fans, and they are renowned to be some of the most fanatical. And so at certain points, you can't, I guess the example here is that you can't rely on fans to behave in accordance with the safety fixtures that are set up in the facility, right? So just because a railing's 42 or guardrail is 42 inches high does not mean you're not going to get somebody who's attempting to climb it or climb over it or stand on it. Or in the example that Dr. Freed gave earlier with the mom and the toddler standing on the picnic table, if you stand on an elevated surface, at least in the OSHA standard, you have completely negated the safety feature of that guardrail. So sometimes we'll see, electrician or a mechanical contractor need to get on a ladder, and they're doing so right adjacent to a guardrail. If I stand on an elevated surface, then it doesn't matter if it's 26 or 42. I've basically taken any of the height requirement out of the equation, and all I have left is a fall hazard. So again, the example here is just that you cannot rely on fans to behave in the way that the facility is designed for. May I have the next slide, please? When the OHS Act was created in 1970, there's one clause that we often repeat. I ask my students to memorize it because it is largely about the spirit of the OHS Act. So I'll just read this. Each employer shall furnish to each of his employees employment and a place of employment which are free from recognized hazards that are causing or likely to cause death or serious physical harm to his employees. Now, the key word in that clause is the employer, and you see the word employer referenced throughout the OSHA standard. And the reasons it's referenced throughout is because it's very clear, for the most part, who the responsible party is in a construction safety situation. There is an employee duty clause for individual, I guess I want to say deviant employees, but for large part, the responsibility lies with the owner. That applies to training, it applies to the communication of hazards, and it also applies to the overall site safety. So a large part of that just falls on the employer. I want to say that that might be related to stadiums and sporting facilities, in that I'm not sure that the line of responsibility is as clear. If it's a facilities maintenance issue, maybe it's the owner who's responsible. If the owner's received notification of a known hazard beforehand, maybe it's the owner. But a lot of times it will be the architect or the engineer or the design team who gets some kind of blowback as to responsibility or why the accident happened. Was it poorly designed or whatever may be the case? In construction, we have a more clear line of liability and responsibility. Now, have the next slide, please. This is basically just a cross section of what we look as a typical guardrail system. Again, we have a little latitude in construction for the top rail. It's 42 inches plus or minus 3. The mid rail is designed to be halfway between there. So it's not always 21 inches, but it's supposed to be halfway up. And then the thing that's actually interesting here is again, I mentioned it's not just about falling people, but falling objects. The last thing is actually supposed to be 3.5 inches. I believe the half inches kind of slipped down one bar, but 3.5 inches is actually a 2x4. It's the actual dimension width of a 2x4. And the principal use or purpose of that toe board is to prevent falling objects like materials, other lumber, tubing from falling into a hole. There is a minimum standard for the gap that's allowed under there, but very strict requirement for falling objects. The only other thing I'd point out to the 1/4 inch nominal diameter or thickness, that would be a wire rope. So again, in steel erection, sometimes we use wire rope instead of 2x4s, or maybe some kind of metal frame guardrail. May I have that next slide, please? You'll note it, you'll recognize some of these numbers. Again, the 200 pounds, that's down and out in the direction of the perceived hazard. That's within the first 2 inches of that top rail. The mid rails are required to have a resistance of 150 pounds, and the toe board is only 50 pounds. May I have the next slide, please? This is just a job built guardrail system, and you don't think what is the relationship between this and something that you might see in a sports facility? Yeah, there are 2 different populations. Usually this guardrail system is intended to stop a human being from falling over the edge or into a hole or some of our larger construction materials, right? If I can job build a railing or a guardrail for 200 pounds, then I surely can do it with stainless steel, which happens to be my personal favorite. But yeah, the materials, notice during Dr. Kocak's presentation, he did not reference lumber. It's not a common material for guardrails. Reason being because it's simply just all other things being equal. It's not as strong as the other materials he mentioned. So from a site safety standpoint, if I can do this in an incomplete construction environment, I certainly can do this in a stadium. The only other thing I mentioned is there's no real flying objects like baseballs or pucks here. So there is no specific requirement for that 4-inch diameter opening where you might have, I guess, a small child's head or a baseball flying at you. May I have the next slide, please? Railings or guardrail heights are dictated, like most other things in the code. When I teach building codes during the fall semester, we usually start with occupancy because occupancy tends to dictate all of the other requirements in the code. So it's almost like a filter system, if you will. You start with occupancy and then you apply the other prescriptive requirements. Again, I don't know if I can see the full section there, but it is in chapter 1015.3. Gives a requirement for 42 inches. It's strict 42 inches, not 42 inches plus or minus 3. May I have the next slide, please? Chapter 10 will in turn refer you to chapter 16. Chapter 16 covers structural design. Dr. Kocak covered some of this already. Chapter 16 will in turn refer, or is in, ASC 7 is the other structural design manual that we use. That's incorporated by reference into chapter 16. And that's where you get the linear load of 50 pounds per linear foot and a concentrated load of 200 pounds. So again, a lot of similarities between OSHA and the International Building Code. You can look for the requirements in chapter 10 that covers guardrails. The structural requirements of such are going to be covered in chapter 16, and ASC 7 is going to be incorporated by reference into chapter 16. So then you would go about designing the specific guardrail system. May I have the next slide, please? Oop, I think we skipped over one. So here's where it gets interesting. We talked a lot about 42 inches. There is what they call a line of sight exception. And that's listed again in chapter 10, but a little farther down. And it's interesting because everything else that you read in the International Building Code or OSHA or even general industry talks about a 42-inch standard as a minimum height. But if line of sight is involved, there is an exception where you can design the railing regardless of strength at 26 inches. Now, in Dr. Kocak's presentation, there were several graphics about the center of gravity with people leaning up against railings. 26 inches is well below most people's center of gravity. So at that point, it becomes, if it's a foul ball, somebody reaching for a foul ball or a t-shirt, it becomes a fall hazard. In stadiums, again, not to go back to the horseplay, but people are doing different things in stadiums where they think they're perfectly safe. There's not necessarily any signage that says warning 26-inch guardrail, as though that was a perceived hazard. If that would be inadequate for OHS purposes. And so people are doing that, but they're also doing things like drinking, jostling, horseplay. The only other thing I was going to mention as far as tolerable behavior in a stadium versus a construction job site, we do not tolerate alcohol on a construction job site. So, and I'm not trying to be the party pooper, but yeah, drinking in combination with a 26-inch guardrail is not necessarily the best combination. I'm not sure if the next slide is mine, but I am done with this one. I think we were all going to talk about this. So these were just some general solutions. There is a suggestion in chapter 24 about using glazing or plexiglass so that you're not interfering with the line of sight, but you're also adhering to the guardrail requirements. The only thing I've heard about that is that sometimes in the 0.6 seconds that it takes to fall 6 feet, it might be a little bit much to ask somebody to latch on or try to attempt to grab a piece of plexiglass versus an actual railing. So I'll let the others speak to these requirements and conclude my remarks there.
Yeah, no, I agree that there is that issue of whether or not you can grab onto it. But if you're intoxicated, or even if you're completely sober and you try grabbing on, how long can you hold on for? Will it be enough? So yeah, the first suggestion was to raise everything up to the 42 inches to provide the greatest level of protection. Now, some might say, hey, that might interfere with the line of sight, but there are strategies that you could examine. For example, moving back the front row, the first row, so you have more space, so it's easier to see because of the angle that you're sitting at. Or it could be to raise it, similar to like an elevated platform that you have for ADA compliance. Or you could do maybe 26 inches for stainless steel or aluminum, whatever it is, and then do something on top of that, such as plexiglass or glass. That is an example that's used. The only other thing that we might see is a little bit different in the IBC is that they say that if you're at the end of a walkway heading down, that you have to have a higher thing. It can't be the 26 inches. It has to be over 30 inches. And I think it's 36 inches, if I'm not mistaken. And so there is that exception. So you'll see it at stadiums where right in front, when you're walking down, they have a heightened level where they might have aluminum and then they have plexiglass on top of that or regular glass. And then back, once you pass that aisleway, you have it back to the lower 26 exemption. Another option is netting. And it's used, as I said before, in Chicago and Seattle. Topgolf, as an example, uses netting to help catch golfers when they fall over. And so the thing is always going to be how to build the best railing system. And that's going to be taking a look at the code, but not being satisfied just with meeting the minimum requirements of the code, because if the code is not where we need to be at, then that is where the problem occurs. And as we saw from one of the previous slides, that code exemption of 26 inches came about in 1929 for the dinner theater type of audience, which is an audience that would be sitting down watching the big bands play or something like that. And that is not how sports are engaged in right now. So the relevancy of what was done in the 20s at that time and that age is completely different from now, where you might have concerts where people are dancing, people are giving each other high fives, turning around, people drinking, people cursing at each other and cursing at the players and things like that. People have just changed their behavior from now to when that section of the code was passed. Next slide. We wanted to make sure we shared our contact information with you, but I think there are going to be a couple questions that might be relevant. So we want to make sure Daniel has the chance to ask us those questions, and then we can have any concluding remarks as well.
Absolutely. Thank you all. I know we spend a lot of time talking about balancing security with the fan experience. And today you all did a phenomenal job in balancing safety with that fan experience and understanding kind of the ins and outs of railing safety and how it can impact our operations. So certainly thank you all for your comments thus far. Before I ask questions, I did want to acknowledge Dr. Grant. I know you are getting toward the 11th hour and you've got to jump off here shortly. So if you do have to go, we completely understand and thank you for your time, but I'm going to start from the top. I have 4 questions that we really wanted to ask that we felt were relevant and pertinent to our audience. So the first question, and please feel free to chime in and answer away. This isn't pointed at anyone in particular, but the first question is for crowd managers. We do a lot of work with our crowd managers. They play a vital role in our venues. What strategies can they take or can be undertaking now to provide the safest possible environment? What can they be doing?
I would like to field that one actually, because it might be my only crack at answering a question because of my time I have to leave. But there were a couple of issues that I really wanted to emphasize about the similarities between an OSHA standard and a facility, how you would operate a construction site and how you would operate a sporting facility. One of them is training. We emphasize training in construction safety with just about everything. We emphasize forethought, planning. So if I'm a crowd manager, I want to know, I want to be able to recognize the hazard. That's the other thing that we look for in construction safety, is just simply recognizing the hazard and being able to pick it off before it actually occurs. So if the crowd managers are looking for warning signs or trained in hazard recognition, which I imagine they are, one of the things that we really emphasize in construction safety is the training. The only other thing that I think might be a little bit different, and maybe we can learn from what we do on construction site, is the signage. So whenever there's a known hazard in an area, we have all kinds of requirements for signage saying warning, danger. They're color coded. Now, I don't think that might go over real well right in front of a 26-inch guardrail, but it is inconsistent with what we've covered so far in terms of height requirement and perceived hazards for falls. The only other thing is I think like some training for the staff management and some really good signage about keeping people where they're supposed to be would be a good recommendation, I think.
Great.
All right. Yeah, thank you very much. Those are great ideas. And I know if you have to go, I understand, because you have to teach, or otherwise your boss might get upset, kind of thing. But Dr. Grant is a firm believer that when we started this research project, he's like, no, it has to be 42 inches. And I kept saying, no, there's a 26-inch exemption. And no, there isn't. Yes, there is. No, there isn't. Yes, there is. As a construction safety, person, Dr. Grant was like, no way, this isn't it. And finally, when push came to shove and we saw the exemption in writing, he was taken aback and like, what is going on in your industry, kind of thing. And so I think that has to be put into the context that for people that work in construction, this is just like a weird exemption and highly inappropriate exemption, if I were to steal Dr. Grant's thunder. But to go back to this question, I think there's a couple things that crowd managers can do. One is warn people. If you're there, you could provide warning to people and say, look at this area, you got to be careful when you stand up here, and you're right by a railing, the railing is low. And I agree, signage could be great if you're not willing to raise your railing height. Maybe put some signage over there, just like you have signage for foul balls. You could monitor intoxicated fans maybe a little bit more, and monitor, so if there's any behavior that looks unusual, try to intervene. Because some of the times I've had cases before, like one at Yankee Stadium a number of years ago, the person didn't fall over the railing, but he fell in an upper deck area and he was having a medical condition, and vertigo can affect people. So it's something to be aware of. Monitor the people in your area. and especially if they're intoxicated or appear to show signs of intoxication, and then remove any tripping hazards. There could be hazards that are blocking the walkway, and that would be a violation of the life safety code to begin with, but that could also represent a concern that someone could trip over something and that could lead them to what might happen. And just look at things from a different perspective, like a fight. It might be, oh, I'm stopping a fight. Oh, I don't want to really stop a fight. I don't want to engage. That might be something that's in the mindset of a crowd manager, but you never know what could happen in a fight. And I actually had a case at a Bon Jovi concert at an arena in Canada a number of years ago. And there was a fight a couple rows up, and one of the people in the fight was pushed over, and he tumbled a couple of rows to somebody who was watching the concert, not even oblivious at all about the fight. And he was rendered paraplegic from being hit from behind. And so monitoring the area and seeing what's going on is so critical, because you never know what might transpire higher up, which can tumble down and transcend, and someone could eventually fall over the railing.
Fantastic. Did you have anything you wanted to add, Dr. Kocak?
Nope, I totally agree with Dr. Grant and as well as the Gilfried. So yeah, that's something that we have to pay attention, and this type of things, unfortunate situations that hurts everybody, and some stuff can be easily prevented by some real easy things that we just don't even realize that. So a little bit of an attention when we are in the games, and as a managers, as the visitors of the venues and stuff. So we really have to pay a little bit of an attention, and we have to use our common sense, which is really important. So I firmly believe that the updates on the codes as well coming soon will make a difference on the unfortunate results here.
All right, fantastic. Now, the second question I have is kind of piggybacking off of that one a little bit. But instead of looking at it from the crowd manager's perspective and the training and recognition that they need to have in place, I wanted to take a second and look at it from the venue manager's perspective. So if you had any suggestions for those venue managers, those people in venue management roles, around the topic of rail safety, what suggestions might you have?
So one that comes to my mind right away is the fan code of conduct. If you have fan code of conduct, enforce it, monitor it, check out what people are doing, and if they're doing something that could be hazardous to themselves or to others, to enforce the fan code of conduct. If you let people get away with stuff, it might accelerate. Also, it's the training of the people to enforce the fan code of conduct is going to be important. One last thing that I think is critical for a venue manager is to regularly check what's going on within your venue. Is there any deterioration of the materials? You don't want to have a situation where you have your concrete falling apart and chunks of it falling down, and then that might impact what's going on. The regular annual inspections required by often insurance companies, that you have to bring in a trained engineer to go in and take a look at your venue. That is so important, because they might be able to identify weaknesses in the railing supports or weaknesses in the lag bolts that are keeping the railing in place, things like that. That is going to be highly critical.
And I would imagine on the opposite end of that spectrum, if you fail to get that annual inspection done and something were to occur, then it obviously increases your liability in relation to that incident. But excellent feedback from the venue manager's perspective. We spend a lot of time talking about having policy, having procedure, but enforcing that policy procedure, making sure your staff is aware of it and prepared to deal with those issues is exceedingly important. So thank you for those answers. The next question is pertaining to the architects and designers working on these venues. If you had suggestions for them, considering the environment and the issues we deal with in sports and entertainment, what might be some recommendations you have for those individuals? Again, the architects and designers.
I mean, I can jump into that question to answer it. So architects and designers are really following the codes giving to them. They're trying, because again, I wish there was just one unique magic material, magic number, the height that we could use for all venues, but definitely it's not the case, and everything individually should be designed. So the importance of the codes here actually making the difference, because architects and the designers are going to follow what's given in the codes. So codes should include, they have to be more inclusive, first of all. And of course, with the new materials that's coming to the, like the carbon fiber materials or composite materials. So there are some places these materials are being, trained, investigated for the possible uses. So by changing these materials, we might really achieve better visibility, affordability, and some other aspects by just really, instead of using the stainless steel or the aluminum alloys or even the carbon steel, structural steel. So we really need to spend some more time on a research really on these occurrences. And definitely 26-inch is not, it is not even my knee actually, height of my knee. It's definitely not a good example of it. Instead of, maybe we can really use the glosses. There are so good, like the tempered glosses that can be used. It's not gonna really protect the visibility or the, at the same time, it's gonna provide really a good, secure environment for the people who might really have these unfortunate situations. So more than the architectural or the designer part of it, more like the code writers. So still they are in conjunction with the designers and the architects. Those codes needs to be updated.
So I would not, that's a great perspective. I would not wait for the code to be, updated, because we don't know how long that's going to take or if it will be taken. So this is where architects and engineers need to come forward and say, yes, there is an exception, but we should not be following that. It is dangerous. And with the information that we know, let's take steps to go beyond to provide the safest environment possible, because that's what is basically the hallmark of the architects and the engineers, is we hire them to make sure the venue is appropriate for its use. And an example that comes to my mind is foul ball safety with netting, that a lot of engineers would say, okay, let's try minimizing it so that way it's not interfering with the line of sight that people might have of watching the game. And over the last couple of years, we've seen how Major League Baseball has extended the netting across almost all of their venues, some of them from foul pole to foul pole, so the entire lower bowl, to protect fans. And the thought was, fans are going to be complaining. They're going to be in an uproar. It's going to be like a revolution. And we're not seeing that. When hockey extended the netting, we didn't see that. So you might say, hey, if we increase the rail height by a little bit, people are going to be in an uproar and we're going to lose revenue and we're going to go broke. And I don't foresee that materializing. What I see is a safer environment for everyone. And I think fans would be thankful for the thought that went into it, that it's not about the revenue. It's about providing a fan experience that is entertaining, but safe.
Understood. And the last question I have, and then we'll wrap up. But the last question I have, we spent a lot of time talking about OSHA and building codes. But if there's one thing we could write in the International Building Code, any way we could, what would we include or change, if anything? And how would it be associated with railing height?
So Dr. Grant is not here. I'll throw in his perspective, which would be get rid of that 26-inch exemption and that it should be a 42-inch high railing. And, that can be done as a combination, as we've talked about before, where it could be partial stainless steel, and then you could have maybe tempered glass or maybe plexiglass or something else on top of it if that is in fact a concern. But it's doing something that codifies that 26 inches is not where we should be anymore, and that we should be at an appropriate height that protects the majority of Americans. And if we're at 99% protection from the the highest people in America at 6'6", that their center of gravity will not throw them over, then that's what we should do.
Understood. Well, again, thank you both so much. But before we wrap up, do you have any final thoughts you want to share with our viewers?
Dr. Kocak, want to go first?
Yeah, thank you. This is really an eye-opening area, and I designed so many different structures as being a civil engineer and a professional engineer. Actually, there's just for parties they're interested more for the design of it. There's a certification actually. You can get certified for designing a commercial and industrial, guardrail systems for fall protections. So if there's anyone interested, I was definitely gonna suggest that. I did it, I took it, and it was very valuable information provided. And it's really showing the the key terms and some of the information. It is really hard to gather. Requires so much of a time to do research on it, but this is really a couple hours of an continued education and development type of an certificate program, and it really helps. So I was going to suggest that any party is interested in getting more information on the design part of it, they should really think about joining this program.
Absolutely, and we'll try to add a resource or a link to that in the resources section of this webinar as well.
Thank you.
And from my perspective, as someone who's been in way too many of these cases, I'm called Dr. Doom and Gloom for a reason, because people don't want to see me because I normally have bad stories, and the bad stories come from real world examples. And we know that people are dying or getting seriously injured from falling over railing or when railing systems collapse. We have to do whatever we can to make sure we're as safe as possible, and doing the least amount to just barely squeak by. It might go to the letter of the law, but does go to the spirit of the law and the spirit of our responsibility to provide the safest environment possible. So I like to end with that thought that, we have to do what is in the best interest of our fans. That should be our top priority. And I have that in my sport facility management textbook as the #1 responsibility for a venue manager, and it applies to everyone working in a venue, is safety of the people in the venue. And that's what we have to do. And that's what made this analysis of railing such an important thing for us to examine, because we had not seen anyone examine it in the detail that we're trying to take a look at, and to bring this to the attention of everyone in our industry, that this is one of the bigger concerns that we're seeing right now. And there should not be any deaths anymore from people falling over railings.
Thank you so much. And we greatly appreciate your participation in this. Dr. Freed, Dr. Kocak, please send our gratitude and our thanks to Dr. Grant as well. This has been extremely informative and valuable to our industry. And with that, we'll close. But again, thank you so much. We're extremely grateful for your participation today.
Thank you, everyone. Stay safe.